Good morning to our lecturer, Dr. Imran, and all my fellow friends. Today, me and my group members are going to talk about PN junction diode. Okay, this is my group member for this assignment 1. Okay, first of all, I would like to talk about literature review. Before we start our assignment, we have read many articles about PN junction diode. In so many articles, we have read an article written by Eddie Simon in year 2007. In the article, it talked about the possibility of using PN junction diode for lifetime and defect analysis in semiconductor materials. Okay. In the next article, we have read the article written by Hafiz Y. Hafiz in year 2016. In the article, it talked about the forward and reverse bias characteristic of PN junction diode using a Catholic 2400 source measure unit. Besides that, we have read an article written by Jirawat Praket in year 2012. In this article, it talked about an improvement of electrical characteristic of PN junction diode by using X-ray irradiation method. The research was carried out to present a new technique of semiconductor fabrication technology, where a soft X-ray annealing method is proposed as a new technique and used in this work. Furthermore, we have read an article written by Yang Wanting, Guo Lingzheng in year 2019. The articles talk about the characteristic of PN junction diode made of multi-layer graphene. Okay, last but not least, we have read an article written by Feng Xiaojing, Xingzhao Liu Yang in year 2018. It writes all about carbon metal PN junction diode. They show that a graphene PN junction diode can be made exclusively from carbon materials by laminating two layers of positively and negatively charged graphene oxide. Now I will pass it to my next groupmate to present more about PN junction diode.
Assalamualaikum warahmatullahi wabarakatuh. I am Siti Nuzulaika binti Jamaluddin. My matrix number is D052010141. Zero bias means that there is no external voltage is applied to the PN junction diode. Since the diode is connected in zero bias condition, there is no external potential energy is applied to the PN junction. However, if the diode terminals are shorted together, a few holes in P-type material with enough energy to overcome the potential barrier will move across the junctions against the barrier potentials. This is known as forward currents and reference is IF. Next, holes generated in N-type material find the situation favorable and move across the junction in opposite direction. This is known as reverse current and the reference is IR. This transfers of electrons and holes back and forth across the junction is known as diffusion. Next, I'm going to explain about zero bias in PN junction diode. As shown in the diagram, the potential barrier that now exists discourages of any diffusion of any more majority carriers to move across the junction. However, potential barrier helps the minority carriers to drift across the junction. Then, an equilibrium or balance will be established when the majority carriers are equal and both moving in the opposite directions, so that the net result is zero current flowing in the circuit. When this occurs, the junction is known to be in a state of dynamic equilibrium. The minority carriers are constantly generated due to the thermal energy. So this state of equilibrium can be broken by increasing the temperature of the PN junction, that causing an increase of generation in minority carriers, thereby resulting in an increased leakage currents, but an electric currents cannot flow since there is no circuit is connected in the PN junction.
Okay, hi, my name is Jackie Janai. unluckily, we can present this presentation face to face, but we do it from virtual. Okay. By the way, just enjoy it. Okay, our team is choose PN Junction, so my part is for yes. Okay, for this, the positive terminal of the source is connected to the P side and the negative terminal is connected to N side. That means PN junction has two side, which is P side and N side. Which one is P side is for positive terminal and N side is for negative terminal. So the external electric field is in the opposite direction, and due to that, the effective electric field at the junction will reduce. The electron in the N-type region and the holes in P-type region will get pushed toward the junction. The width of the depletion region will reduce. The effective resistance which is offered by the depletion region will also reduce. That means if the width of the lesion reduces, that means the resistance also will reduce. Okay, that means if one is reduced, so the other one is need to reduce also. Okay, the external applied voltage, the width of the lesion region will further reduce. The more reduced, we get the mostly rigid, like that. When the applied voltage is more than the barrier potential of the PN junction, then the resistance that is offered by depletion region is negligible. For example, for the silicon crystal, if the applied external voltage is more than the 0.7 volt, once they come into the P side region, then just by passing through the holes in P. This means that current just passing through the holes only. Okay, they can reach the positive terminal of the battery, and similarly the holes will be pushed toward the tertiary region, and once they enter the N secondary. So when they enter the holes, and then they also can enter the N side region. Then they will get attracted towards the negative terminal of battery because of the charge of north and south. Okay, so in this way, we get a flow of current due to the movement of holes as well as electron. As we increase the externally applied DC voltage, the more electron and the holes will be able to cross this depletion region. Due to that, they will contribute in the flow of current. So, as we increase the external applied voltage, the flow current in the circuit will increase. So, that means more applied voltage, more flow current will in the circuit will increase. Okay, that's all from me. Thank you.
Salam sejahtera diucapkan kepada doktor. My name is Konehi Pei and my matrix number is D0520101112, and I will explain about the reverse bias of the PN junction diode. I will start my presentation with the properties of reverse bias. A diode is called reverse bias when it is biased in the reverse direction, which means the positive terminal of the source is connected to the N-type and the negative terminal of the source is connected to the P-type, which represented by the diagram. The potential barrier of the germanium is 0.3 volt and for the silicon is 0.7 volt in the condition that there is no voltage supply to the diode and the temperature is around 25 degrees Celsius. Now I will explain about the working principle of the reverse bias. When the negative terminal is connected to the P-type of the semiconductor, the holes are attracted towards the negative terminal. When the positive terminal is connected to the n-type of the semiconductor, the free electrons are attracted toward the positive terminal. The free electrons from n region will combine with the holes at the p region and create more positive impurity ions. The negative ion at the p region will oppose the flow of the free electrons from the n region. The holes will combine with the free electrons at n region and replace the electron's original position. The positive ion at the n region will oppose the flow of the holes from the p region, so that the depletion layer will become thicker and difficult the flow of the electric current. However, a negligible small reverse leakage current still can flow through the junction due to the minority carriers that are generated the electrons in p-type of the semiconductor and the holes in the n-type semiconductor. If the applied reverse bias voltage is sufficiently high, the depletion layer will disappear due to the Zener breakdown and the avalanche breakdowns.
Good morning, sir. Now I explain about the theory of p-n junction diode. I will using the graph to explain the theory. The F for the graph is forward bias and the R is the reverse bias. Firstly, if we use the graph, we need to find the knee voltage and the reverse breakdown voltage. If we find that knee voltage at this point, we can simply say that the line above the knee voltage is forward bias. And if we find that the reverse breakdown voltage at this point, we can simply say that the line with the reverse breakdown voltage is reverse bias. And the straight line after the reverse breakdown voltage is called breakdown region. Next, I will explain about the equation. The equation that we use to calculate the p-n junction diode is ID equal to IS bracket E powered by negative VD divided by N VT and negative 1 close bracket. ID is the diode current and IS is a diode reverse saturated current. E is the Euler number, which is 2.718281828. VD is the external voltage applied to the diode. N is the identity factor, which are 1 for germanium, 2 for silicon. And VT is the terminal voltage we need to calculate by using another formula, which is KT divided by Q. K is the Bowser constant, which is 1.38 times 10 powered by negative 23. And T is the temperature of the diode junction. Q is the charge of the electron, which is 1.6 times 10 powered by negative 13. If we simplify the formula, we can get that the forward bias in room temperature for the germanium diode is this formula. ID equal to IS bracket E14 V negative 1. And for the silicon diode, we can get that ID equal to IS bracket E20 V negative 1 close bracket. And for the germanium diode in reverse bias condition, we can get that ID equal to negative IS.
So now we are at the conclusion of the presentation. The conclusion is the forward bias and reverse bias properties of the p-n junction imply that it can be used as a diode. Next, a p-n junction diodes allow electric charge to flow in one direction, but not in the opposite directions. This happens because electric charge can easily flow through junction from N to P, but not from P to N, and the reverse is true but only for holes. Next, when the p-n junction is forward biased, the electric charge flows freely due to reduce the resistance of the p-n junction. Meanwhile, when the p-n junction is reverse biased, the junction barrier becomes greater and the charge flows is very small.